So electronic configuration is arrangement or allocation of electrons in the sub-energy levels of an atom of an element in a periodic table. So in other words, electronic configuration is the key to understand periodic table. Periodic table is an important basic thing in inorganic chemistry. It tells us the location of an element in periodic table. So the modern periodic table was presented by Mosley after Mendeley, and it consists of 7 periods and 8 groups, all arranged according to electronic configuration, like hydrogen is at number 1 position, helium number 2, lithium 3, beryllium 4. Similarly, all 118 elements are arranged depending upon the electronic configuration in the outer shells. So, in pairs, the elements are arranged according to the increasing number of electrons in the same outer shell, and in groups the number of shells are increased and the electronic configuration in the outer shell remains same. In an atom, nucleus is surrounded by shells like K, L, etc. So number of electrons in a shell are in the order K, L, Mn, and the total number of electrons in a shell are derived from 2n square. In first shell, the number of electrons are 2, second 8, third 18, fourth 32, and fifth shell 50 electrons. So as we have discussed earlier, in groups, the total number of electrons in a shell remains outer shell remains same. Like in first shell, the number of outer electrons are 1, and the shells are increased when we move from upward to downward direction, but the number of electrons in outer shell remains same. Opposite to this, when we move left to right in a period, the number of electrons are increased, like hydrogen 1 and helium 2, but the shell number remains same. And in second period, when we move from lithium to neon, the shell number remains same, but electrons are increased. Similarly, protons are also increased. So that's why when we move from left to right, atoms are shrinked, and when we move from top to bottom, atom size is increased. So there are 4 sub-energy levels like S, P, D, and F. S is spherical in shape, P is lobed, and D is dumbbell in shape. The azimuthal quantum number for S is 0, for P is 1, and D is 2. This azimuthal quantum number tells how much electrons can be accommodated in an orbital. So for S, there is azimuthal quantum number 0, which means it has only one part, and 2 electrons can be accommodated in S orbital. So P have azimuthal quantum number 1. So when we put 1 into L plus 1, it means 3. So 3 for P orbital means it have 3 parts, Px, Py, and Pz. 2 electrons are placed in each part, and there are total 6 electrons are placed in P orbital. So 2L plus 1 indicates the number of parts. So for D, the number of parts are 5, and for F, number of parts 7, and so 10 electrons are placed in D orbital and 7 are placed in F subshell. So each orbital can accommodate up to 2 electrons maximum, not minimum. So in S, as it have only one orbital, the total number of electrons accommodation is 2. In P, there are 3 orbitals, so total accommodation is 6. And in D, there are 10 electrons are accumulated because it have 5 parts and azimuthal quantum number value is 2. And for F, there are 14 electrons can place in this complex shape orbital type, and this azimuthal quantum number value is 3. Now we proceed for electronic configuration. Before proceeding, we should know what are the rules. So the first one rule is aufbau rule, which indicate the electrons are arranged in an atom according to increasing energy level. First, electrons are placed in lower energy levels, then electrons are placed in higher energy levels. The low energy orbitals are occupied first, then higher energy orbitals. So the Hunds rule, if degenerate orbitals are available, the electrons are distributed equally among them. Pauli exclusion principle, sorry, it's not Pauling, it's Pauli exclusion principle. No two electrons can have same set of four quantum numbers, while the spin state of electrons are opposite like you. It have two definitions. For example, there are four quantum numbers and and two same electrons in orbital cannot have four quantum number values same, but one value like spin quantum number is different, like the spin states are different. So these two are incorrect and third one is correct. So we move to the main topic. For electronic configuration we need to draw, we need to draw this type of diagram. First we put one first shell configuration, then second shell, fourth shell, five shell and six shell. In first shell there only one orbital is 1s, and second shell 2s and 2p. D starts from third shell 4f, f starts from 4 and goes to 5 6. So when we write electronic configuration, first we write 1s, then 2s, then 2p, then 3s, 3p, 4s, 3d, 4p, 5s. So Horn's rule indicate that when sorry, Pauli exclusion principle, aufbau principle, and Horn's rule principles are considered while writing this electronic configuration. Electrons are arranged increasing energy level. 1s is low energy, 2s. So for 4s and 3d, if we consider the aufbau principle, then 4s have low energy. Its azimuthal quantum number for s is 0, and 4 plus 0 is 4, and for d azimuthal quantum number is 2, and for d as it is 2, therefore 3 plus 2 is 5, therefore it is placed after 4s. So for lithium, atomic number is 3, and we should write 1s and 2s 1. 1s2 and 2 is 1. Carbon 1s2, for carbon it is 1s2, 2s2 and 2p2. And Horn's rule indicate the if degenerate orbitals are available, then electron placed are equally in 2px and 2py. Similarly, for sodium 1s2, 2s2, 2p6, 3s1, and for zinc 1s2, 2s2, 2p6, 3s2, 3p6, and after 3p we place 4s2, not 3d in chronological order. We place 4s after 3p. So you should draw this diagram before writing electronic configuration to remember which orbital is after which orbital, because the energy of 4s is lower than 3d, but in order it seems lower, like it is 3 and it is 4, but it is third shell orbital, but its energy is higher than its 4 shell 4s orbital. So therefore in electronic configuration 4s2 is prior to 3d. These are the examples of electronic machine. For further you can contact us. Chemistry by Muhammad Usman. Thank you very much.